We have a very interesting episode this time. I don't know who know it, but there was a big bridge collapse in Germany. It was taking place in the city of Dresden, and there was a huge bridge collapse in the night. Lucky-wise, nobody was hurt, and we was thinking about immediately afterwards, maybe it's a good idea to scan this, to have these documented. And in this video, you have the option to see our results. Stay tuned if you're interested. At the beginning, I like to show you the bridge before the bridge was collapsed. This was taking place in the city of Dresden, which is East Germany. Dresden is a bigger city, like 500,000 people. And this one is an important bridge in the city. You see the city is located on the river Elbe and have only a few bridges. There's the highway bridge, and then you have it's only about 6-7 bridges in the city, and this is the major one because these bridges collected this main part here, and it's also with the other side. So it's a very important bridge because the bridge have also a big capacity. You see there, this was taken from Google during the construction. The bridge have two parts. So this is the A, B, C part, and A and B was for road, and the C part was for the city train, the tram. So there is already here some pictures. So that was like the bridge was looking before. So you had this line, and then this on construction was the other lines, like 2 lines in each direction, was a very important connection in the city. And then you here on the left side, you have the city train rail connection. They're going this. In this part was collapsed at the 11th of September to 24. Lucky-wise, 3 in the morning, like 15 minutes before, last passed this area, and then the bridge collapsed, and lucky-wise nobody was hurt, but the bridge is actually then totally collapsed. So afterwards, immediately, this was under the week, on the weekend, I had to do something on the university in Dresden because I studied there. I put one of our scanners and say, oh, let us do some scans from this event, so maybe we have some data that's interesting. This area was then total blocked for security, and there was also immediately they have to take out some of the collapsed bridge parts because there was a high water coming up, and they want to take everything out that they can. In high water cases, the water can go from this side to the other side and will be not blocked and flooding the city. There was like a total block. There was a lot of construction. Even the army, like the engineering corps of the army, been there. Like all people from the city was looking there. Governmental official person, the army guys, main TV station was totally crowded. I think we was not able to scan under the weekend, so there was too much going on there. So, and then I leave the scanner there in our local office in Dresden, and my colleagues then later scan under the week this part, and they're scanning from this side somewhere, I think up here. I know the area well because I study in Dresden, and this part, if you like to be in surveyor, this part is part of the exercise field from the Application Science University of Dresden if you like to study surveying. So there was knowing that we can stay somewhere here. We had one position here. Then my colleague moved from the other side and make a position here. We had some position here and some there. We was not allowed to go on the bridge or below the bridge because we was not official governmental person and don't have a job there. So we take it like everybody else can take this. We use the Teledyne Optic Polaris. This is a long-range scanner from the Canadian company Teledyne. It's not actually not produced anymore, I think so, but it's a very good machine, and we have the H long-range version, and this version is up to 2 kilometers. If you look, I think we checked this is maybe 200 to 300 meters. But this scanner is very interesting for the task because it's one of the scanners who have a different measurement mode. Most other scanners having like a laser beam and using a rotating mirror to bring the laser in the space, and then the complete system turns. And this system is like only a window scanner and is not working on rotation. This is working on an oscillation system, and this allows you to have a lower resolution, as the higher resolution, as a lower distance between 2 points. And that's very important. If you stay more far away, you need a high resolution to see any details on the object, what you like to scan. And that's why we choose this system. And how the results looks, and that's was some of the scans. We don't, in this view, can show you all scans because the data set are super huge, and then my viewer program, free Cloud Compare, goes a little bit slow. But look, that is the part, you know, we have these two parts. This is the part where the streets are on, and this is this part where the railway is, and this part was collapsing. And you can really good see how here is this really broke in pieces here. You see, even you see the side, the handrail or the fence on the side. And this one was then going in the River Elbe. We get only a few points because we can measure under the water. Here you see already the cable connection, and this is the other side of the collapsed bridge. And we have also some details here. So, as I mentioned, we don't have we do it by ourselves. We get the scanner, scan this by our own. We don't have an official job for that. We don't get money. But as I said, if you are like a German governmental offices, or you are like a university for bridge construction in Germany, and you are interested to get this data set, we will share this for free for you. So you can contact us. So you see the other details. And then to make it better views, we calculate a video flow over the whole bridges with the whole data set. But you can see with the scanner, you can really capture details. And now we've frozen the scene when somebody can use it, and we have 3D points and you can measure. We have also more far away points, because we have this very long-range scanner, and then you see we not have any data on top of the bridge because we're standing below the bridge. We not can measure on top, but we have some information from the side and also from below. And what's interesting now, in the second part of the video, where you can see here, this is the crashed tram line. So and that's now the second part, and now we take you on a virtual ride on the crashed part of the bridge. So that is the piece what is now laying in the water. And here you see here already the tram line, and here are the broken points, and this part was up, and you see there's also some demolition working still going on, as this was already taken away, and the complete part of left side of the bridge was also out. So, but you can see how this bridge collapse looks really in 3D. It's a big crash you see here. It's a big bridge, it's not a small one. So it's a big event happen, and with this video we can show you how we can frozen realistic crimes, I want to say about Havery scenes, and make this frozen, and we have the data for research already. But we also use the same technology to scan existing bridges. They're lucky-wise not collapsed, to make a digital model from the existing situation. Then this data go direct to design engineers for road and bridge design, and based on this data set they make a renovation of bridges or a demolition of an existing bridges and replace it by new bridges. This is another use case what we use typical, where we are more interesting to make existing bridges better and newer as scanning crash bridges. I think that's something what nobody likes. So, and with this, I'm more or less on the end of this episode. Don't forget, like every time, leave a comment or give us a thumb up or subscribe to the channel if you like to stay tuned and see more cool stuff, what you can do with your laser scanner. Bye-bye, Eric.